Here we'll look at nth roots. And these are similar to square roots, only we're going to be looking at higher powers. So we denote this by writing the square root of a with this little n at the top. And what this means is this is equal to b whenever b to the nth power is equal to a. So in the case that n is equal to 2, this is just the square root. If we want to look at the cube root of a, we want to know what number cubed is equal to a. The fourth root of a, what number to the fourth is equal to a, etc. Here we'll look at a few examples. The first one, the cube root of 27. So we need a number that times itself 3 times is 27. And we can see that this is 3, since 3 times 3 times 3 is equal to 27. The cube root of -8. When we were dealing with square roots, we could not take the square root of a negative number. However, if we're taking an odd power root, then we can take negative numbers. For instance, -2 times -2 times -2 is -8. So the cube root of -8 is -2. Another one, the fourth root of 1/81. We know 1 times itself 4 times is 1. And 3 times itself 4 times is 81. For the sixth root of -2 to the sixth, since 6 is an even power, we're going to need to take the absolute value whenever we do this. And we just get 2. When simplifying these, we're going to have 3 main rules. And here is the first one. If I take the nth root of a product, I can break a root up over a product. My second one states that I can also break these roots up over division. And then the last says that I can pull exponents out. So for example, if I want to look at the square root of 32, we can't actually take the square root of 32, but we may be able to simplify this. Well, we know that 32 is really 16 times 2. And by the first rule, we can break this up to get the square root of 16 times the square root of 2, and we know what the square root of 16 is. It's 4. So I have 4 square root of 2. For my second example, I know that 81 is 27 times 3. So I have the cube root of 27 times the cube root of 3. And I know the cube root of 27 is 3. So I have 3 times the cube root of 3. And whenever we're looking for what to break this into, we're looking for things that we already know. We knew the square root of 16 and we knew the cube root of 27. So we're trying to write these in terms of things that we already know. A few more examples. This one seems a little bit trickier to break up, but we're going to break it up as -8x cubed times the cube root of 2x squared. We can see that -8 times 2 is -16, and x cubed times x squared is x to the 5th. The cube root of -8 is -2, and the cube root of x cubed is x, since a cube root and a cube will cancel each other out. And then I have this cube root of 2x squared left. For my next one, I'm going to break this up a little bit more strangely. I'm going to have the fourth root of 81x to the 4th over 16 times the fourth root of x cubed. So this does get me back to where I wanted. And it looks a little strange, but the truth is the first root that I've written here, we know all of these fourth roots. We know that the fourth root of 81 is 3, the fourth root of x to the 4th is x, and the fourth root of 16 is 2. So now I'm only left with this fourth root of x cubed. We can also look at adding and subtracting these. However, we need the roots to be the same. Here I'm going to rewrite this. 12 is the same thing as 4 times 3. And I know the square root of 4 is 2. So now I have negative 5 times 2 root 3 plus root 3. So this says negative 10 square root of 3 plus the square root of 3. And now I can add these the same way I would polynomials. Negative 10 plus the 1 gives me negative 9 root 3. One last example. This one looks a little bit more confusing to break up, but we can do it. I'm going to start with this first one. I know the cube root of 8, and I also know the cube root of x cubed. And so then I also am left with an x squared. For the second one, I know what the cube root of negative 1 is, and then I'm left with x squared. And then my last one, I know the cube root of 27, and I'm left with an x squared. So this becomes 2x cube root of x squared minus the cube root of x squared plus, this is 2, and this cube root of 27 is 3, so plus 6 cube root of x squared. I can try to add the numbers in front. And I'm going to start with doing these for the last two. Negative 1 plus 6 is 5. If I try to add the numbers in front here, I can't add this because it has an x. One has an x and one doesn't. But I can write it as 2x plus 5 times the cube root of x squared, where I basically factored out what they had in common.